The universe might be a simulation, and we're glitching. What if everything you know is a lie? What if the stars above, the ground beneath, even your thoughts, are part of a grand illusion? A simulation. You wake up. You breathe. You feel. You think. But what if none of it is real? There are moments, fleeting, strange, when reality seems to glitch. Déjà vu time slips. The Mandela effect. People disappearing. Memories that don't align. You shrug it off. Everyone does. But deep down, something feels wrong. You felt it. That eerie sensation that someone, or something, is watching. Not from the shadows, but from beyond. The simulation hypothesis isn't just science fiction anymore. It's a theory gaining traction among physicists, philosophers, and technologists. It proposes that our universe, everything we perceive, is a sophisticated simulation, run by an advanced intelligence, for reasons we cannot comprehend. And here's the terrifying part. We might be glitching. The signs are subtle, but they are growing. Unexplained phenomena, quantum anomalies, consciousness behaving like a rendering engine. This isn't just a story. It's a journey into the deepest questions of existence, into the unsettling possibility that we are not real. In this video, we'll explore the simulation hypothesis. We'll dive into the science, the philosophy, the glitches, the horror. We'll examine ancient clues, modern technology, and the psychological terror of being simulated. Are we players or NPCs? Is consciousness the key or the trap? And if we are inside a simulation, who or what is watching? Welcome to the mystery. Welcome to the glitch. Welcome to the simulation. The simulation hypothesis. Imagine a civilization so advanced, it could simulate entire universes. Not just virtual worlds like we see in video games, but full-scale realities indistinguishable from the real thing. This is the core of the simulation hypothesis, a theory that suggests our universe might be one of countless simulations run by a higher intelligence. The idea gained mainstream attention thanks to philosopher Nick Bostrom. In 2003, he published a paper that shook the foundations of reality. His argument was simple, yet profound. At least one of the following must be true. 1. Almost no civilization reaches a level of technological maturity capable of creating simulations. 2. Advanced civilizations have no interest in running simulations of their ancestors. Or 3. We are almost certainly living in a simulation. Bostrom's logic hinges on probability. If future civilizations can and do run ancestor simulations, the number of simulated beings would vastly outnumber the original biological ones. Statistically, it becomes far more likely that we are among the simulated rather than the simulators. This isn't just philosophical speculation. It's rooted in technological trends. Consider the exponential growth of computing power. Today's video games already simulate complex environments with realistic physics and AI-driven characters. Virtual reality is becoming immersive. Neural networks are learning to mimic human behavior. If this trajectory continues, it's not far-fetched to imagine a future where entire conscious experiences are simulated. But what does it mean to be simulated? Are we just lines of code? Is consciousness an emergent property of complex computation? These questions blur the line between science and metaphysics. If our thoughts, emotions, and memories are part of a simulation, then what is the nature of the self? Some argue that being simulated doesn't diminish our experiences. Pain still hurts. Love still feels real. The simulation, if it exists, is perfect enough that our reality functions as it should. But others find this notion deeply unsettling. It implies a lack of agency, a loss of authenticity. If we are being watched, tested, or manipulated by unseen programmers, then free will becomes an illusion. The simulation hypothesis also raises ethical questions. Would a simulated being deserve rights? Could suffering in a simulation be morally wrong? If we ever create our own simulations with conscious entities, what responsibilities would we bear? Interestingly, ancient philosophies echo similar ideas. Hinduism speaks of Maya, the illusion of the world. Plato's allegory of the cave describes people mistaking shadows for reality. Gnostic texts suggest the material world is a false construct. These metaphysical traditions may have intuited what modern science is only beginning to explore. Skeptics argue that the hypothesis is unfalsifiable, we can't prove or disprove it. But proponents counter that certain clues might exist. The mathematical nature of physical laws, the pixelation of space-time at the Planck scale, and the behavior of quantum particles when observed, all hint at a programmed reality. Even Elon Musk has weighed in, stating that the odds we're in base reality are 1 in billions. Ultimately, the simulation hypothesis forces us to confront the nature of existence. It challenges our assumptions about reality, consciousness, and identity. Whether true or not, it opens a door to profound inquiry, and perhaps, a deeper understanding of what it means to be human. In the chapters ahead, we'll explore the evidence, the anomalies, and the psychological impact of living in a world that might not be real. But for now, let this idea settle in. You might be a character in a cosmic program, running on a machine beyond comprehension. Glitches in the Matrix. There are moments in life that feel off. You walk into a room and feel like you've been there before, not just once, but in a way that defies logic. You remember events that others insist never happened. You see time bend, stretch, or collapse in ways that leave you breathless. These are the glitches. And they might be the cracks in the simulation. Déjà vu is one of the most common and unsettling experiences. That eerie feeling that you've lived a moment before, not similar, but exactly the same. Scientists attribute it to memory processing errors, a misfire between short-term and long-term memory. But what if it's more? What if déjà vu is a momentary overlap in simulation code, a rerun, a loop, a hiccup in the system? Then there's the Mandela effect. Named after the widespread false memory that Nelson Mandela died in prison in the 1980s, despite historical records showing he lived until 2013. People remember events, logos, names, and timelines differently, with conviction. Is it collective misremembering? Or is it evidence of parallel simulations, merging or diverging? Time slips are even more bizarre. Individuals report stepping into places where time seems to stop or rewind. A man walks into a store and finds it filled with items from decades past. A woman drives down a road and suddenly finds herself in a different year. These stories are rare, but consistent. They suggest temporal instability, a glitch in the rendering of time. Quantum physics adds fuel to the fire. The observer effect, where particles behave differently when observed, implies that reality is not fixed, but responsive. Like a video game that renders only what the player sees. If our universe behaves this way, it supports the idea that we're inside a system designed to conserve processing power. Entanglement is another anomaly. Two particles, separated by vast distances, affect each other instantaneously. Einstein called it spooky action at a distance. In a simulation, this could be a shortcut, a way to maintain consistency without physical connection. Psychologically, these phenomena challenge our sense of reality. The brain is wired to seek patterns, to make sense of chaos. When reality doesn't conform, we experience cognitive dissonance. Some dismiss it as hallucination or stress. Others see it as awakening, the moment the illusion falters. Philosophers have long questioned the nature of reality. Descartes wondered if a demon was deceiving him. Modern thinkers ask if we're in a dream, a program, a construct. The glitches give weight to these questions. They are the anomalies that suggest something deeper. Technology mirrors these ideas. In video games, glitches occur when code fails to execute properly. Characters walk through walls, environments flicker, time loops. These errors are visible signs of an underlying system. If our world shows similar signs, what does that say about its architecture? Some researchers propose that our brains are tuned to a frequency, a bandwidth of reality. When that frequency shifts, we perceive glitches. Meditation, psychedelics, trauma, all can alter perception. Are these tools to see the code? Or are they distortions? The implications are profound. If glitches are real, they suggest a system with flaws. And if the system has flaws, it was built. By whom? For what purpose? Are we entertainment, experiment, or education? In the next chapters, we'll explore the physics that feels programmed, the role of consciousness, and the ancient clues that hint at simulation. But for now, consider this. Every time reality feels strange, every time you question what's real, you might be glimpsing the edge of the code. Physics that feels programmed. Physics is often described as the language of the universe. But what if it's more than a language? What if it's code, elegant, efficient, and deliberate? The laws of physics are astonishingly mathematical. Gravity, electromagnetism, thermodynamics, all governed by equations that fit on a chalkboard. This elegance has long puzzled scientists. Why should reality be so clean, so computable? Some argue that this mathematical precision is evidence of design. In a simulation, rules must be consistent and optimized. Just like a video game engine, the universe may rely on algorithms to maintain order. Take the Planck length, the smallest measurable unit of space. It's not just tiny, it's a hard limit. Nothing can be smaller. In digital systems, resolution limits define how finely data can be rendered. The Planck length may be the pixel size of our universe. Then there's the speed of light. It's not just fast, it's the cosmic speed limit. No information can travel faster. In computing, processing caps prevent overload. The speed of light may be the maximum data transfer rate in our simulation. Physical constants like pi, the gravitational constant, and the fine structure constant are eerily precise. They never change. In programming, constants are hard-coded values that ensure stability. Could these be the parameters of our cosmic software? Quantum mechanics adds another layer. Particles exist in probabilities until observed. This resembles rendering, where environments are generated only when needed. It's efficient. It's smart. It's suspicious. Even the vacuum of space isn't truly empty. It teems with virtual particles popping in and out of existence. Like background processes in a computer, they are invisible but essential. Cosmologists have noted that the universe seems fine-tuned for life. If certain constants were even slightly different, stars wouldn't form, chemistry wouldn't work, and life would be impossible. This fine-tuning could be coincidence or configuration. Some physicists propose that the universe is a cellular automaton, a grid of discrete units updating based on rules. This idea mirrors digital simulations, where space and time are quantized. The holographic principle suggests that all the information in a volume of space can be described by data on its boundary. It's as if the universe is a projection, a rendering from a two-dimensional codebase. Even black holes, once thought to be cosmic dead ends, now appear to store and emit information. Stephen Hawking's work on black hole radiation implies that data is never truly lost. In a simulation, preserving data is crucial. Theoretical physicist James Gates discovered error-correcting codes embedded in string theory equations. These codes are used in computer systems to detect and fix errors. Why would they appear in the fabric of reality? Critics argue that these patterns are coincidences or artifacts of human cognition. We see design because we seek it. But the consistency, precision, and efficiency of physical laws suggest more than randomness. If the universe is programmed, who wrote the code? Is it a civilization beyond time? An artificial intelligence? A cosmic architect? And if physics is code, can it be hacked? Can we manipulate the rules, change the constants, rewrite reality? In the next chapters, we'll explore consciousness, ancient clues, and the psychological horror of being simulated. But for now, ponder this. The universe behaves like a machine. It runs on rules. It conserves energy. It processes information. Maybe it's not a machine. Maybe it's a program. Consciousness and the observer. Consciousness, the great mystery. It is the lens through which we perceive reality, yet its nature remains elusive. In the context of the simulation hypothesis, consciousness may not just be a passive observer. It might be the rendering engine itself. Quantum mechanics offers a strange clue. The observer effect reveals that particles exist in a state of probability until measured. Observation collapses the wave function, turning potential into reality. This suggests that consciousness plays a fundamental role in shaping the universe. In a simulation, rendering only occurs when needed. Video games don't generate entire worlds at once, they render what the player sees. Could our universe operate similarly? Is consciousness the trigger that brings reality into existence? This idea challenges materialism, the belief that matter is primary and consciousness emerges from it. Instead, it suggests that consciousness might be primary, and matter arises from observation. Philosophical debates swirl around this concept. Solipsism posits that only one's own mind is certain to exist. Everything else could be an illusion. Panpsychism argues that consciousness is a fundamental feature of all matter, that even atoms possess awareness. If consciousness is universal, then the simulation might be a shared dream, a network of minds interacting within a coded framework. Or perhaps it's a single mind, simulating itself endlessly. The NPC question arises: are we autonomous beings, or scripted entities? In video games, non-player characters follow routines, respond to stimuli, but lack true agency. If we are in a simulation, how can we tell if we're players or NPCs? Some suggest that self-awareness is the key. The ability to question, to reflect, to doubt, these may be signs of player status. But even advanced AI can mimic these traits. The line blurs. Near-death experiences, psychedelic visions, and mystical states often reveal realities beyond the physical. People report feeling connected to a greater intelligence, seeing the code behind the curtain. Are these glimpses of the simulation's architecture? Lucid dreaming offers another clue. In dreams, we can become aware, manipulate the environment, and interact with dream characters. The parallels to simulation are striking. What if waking life is just a more stable dream? Consciousness also defies localization. Despite decades of neuroscience, no single region of the brain has been identified as the seat of awareness. It's distributed, emergent, and mysterious. Some theories propose that consciousness arises from quantum processes in the brain, microtubules interacting with quantum fields. This would link the mind directly to the fundamental fabric of reality. In a simulated universe, consciousness might be the interface, the user experience layer. It interprets data, renders environments, and creates meaning. Without it, the simulation is inert. This raises ethical questions. If consciousness is the renderer, then every sentient being contributes to reality. Every perception matters. Every experience shapes the world. It also suggests that awakening, becoming aware of the simulation could alter its parameters. Like a lucid dreamer changing the dream, a conscious entity might influence the simulation. Are we meant to awaken? Is the simulation a test, a game, a school? Or is it a prison, designed to keep us unaware? In the next chapters, we'll explore ancient clues, modern technology, and the psychological horror of being simulated. But for now, consider this. You are conscious. You observe. You render. Maybe that's the glitch. Maybe that's the key. Ancient clues and mythological echoes. Long before computers, before quantum physics, before the word simulation even existed, ancient civilizations were already asking the same haunting question: is this world real? Across cultures and centuries, mythologies and metaphysical traditions have described reality as an illusion, a dream, a construct. These ancient echoes may be more than poetic metaphors. They might be early glimpses into the simulation. In Hindu philosophy, the concept of Maya is central. Maya is the illusion, the veil that hides the true nature of existence. The physical world is seen as a deceptive appearance, masking the eternal, unchanging reality of Brahman. This idea aligns eerily with the notion of a simulated universe. What we perceive is not the source, but the projection. Plato's allegory of the cave offers another striking parallel. In this story, prisoners are chained inside a cave, watching shadows cast on a wall. They believe the shadows are reality because they've never seen the outside world. When one prisoner escapes and sees the sunlit world beyond, he realizes the truth, and is met with disbelief when he returns. Plato's cave is a metaphor for awakening from illusion. In simulation terms, it's the moment a character realizes they're inside a program. Gnostic cosmology takes it further. Gnostics believed the material world was created by a false god, the demiurge, who trapped divine souls in a flawed reality. Salvation comes from gnosis, or hidden knowledge, that reveals the truth. This dualistic worldview, a false reality hiding a divine source, mirrors the idea of a simulation run by an imperfect or malevolent intelligence. Buddhism teaches that attachment to the physical world leads to suffering. Enlightenment comes from seeing through the illusion, recognizing the impermanence and emptiness of all things. The simulation hypothesis echoes this. If the world is not real, then clinging to it is futile. In Norse mythology, reality is shaped by fate and prophecy, woven by the Norns. The idea that destiny is scripted, that events unfold according to a hidden code, resonates with the concept of a programmed universe. Even Christian theology contains simulation-like themes. The idea of a divine plan, of being watched and judged, of a final revelation, all suggest a structured reality with purpose and oversight. Shamanic traditions speak of other realms, accessible through altered states. These realms often feel more real than the physical world. Are they alternate simulations? Layers of code? Or glimpses beyond the veil? The consistency of these themes across cultures is striking. They all point to a hidden truth, a deeper reality, a sense that what we see is not all there is. Modern thinkers have begun to reinterpret these myths through the lens of simulation. What if ancient seers, mystics, and prophets were intuitively sensing the architecture of a simulated cosmos? Carl Jung spoke of archetypes, universal symbols embedded in the collective unconscious. These patterns may be the code of the psyche, recurring motifs in the simulation's narrative. Joseph Campbell's hero's journey, a universal story structure found in myths worldwide, could be the algorithm of transformation, a script embedded in the simulation to guide consciousness. The ancients didn't have computers, but they had insight. Their metaphors may have been primitive descriptions of what we now call code, rendering, and artificial reality. In the next chapters, we'll explore how modern technology is catching up to these ancient visions, and how the psychological horror of being simulated is becoming a real concern. But for now, consider this. The myths were warnings. The stories were clues. And the illusion may have always been the simulation. The cracks in reality. Imagine standing at the edge of a vast digital landscape, a horizon stretching endlessly, yet somehow incomplete. The sky above is painted with stars, but as you stare longer, you notice something unsettling. The stars seem to repeat, like a pattern copied and pasted across the heavens. It is as if the universe itself is stitched together with code, and every so often, the seams begin to show. This chapter is not about myths or ancient whispers, nor purely about the terror of being trapped in a simulation. It is about the cracks, the subtle fractures in reality that suggest the system holding our existence together is not flawless. If the universe is a program, then like any program, it glitches, it falters, and sometimes, it reveals its scaffolding. The digital mirage of physics. Physics has long been our anchor, the set of rules we trust to explain the cosmos. Gravity pulls, light travels, entropy increases. Yet, beneath this apparent solidity, anomalies lurk. Quantum mechanics, for instance, is riddled with paradoxes. Particles behave like waves until observed, collapsing into certainty only when measured. This is not the behavior of a physical object, it is the behavior of information, of data awaiting a command. Consider the Planck length, the smallest measurable unit of space. Why should reality have a minimum resolution? Why should there be a pixel size to existence? It is as if the cosmos is rendered on a grid, each point a coordinate in a vast simulation. Just as a video game cannot render infinitely fine detail, perhaps our universe is constrained by computational limits. The Planck length is not just a curiosity, it is the boundary of the code. And then there is the speed of light, the ultimate speed limit. Why should such a limit exist? In a simulation, it makes sense. No system can process information faster than its hardware allows. The speed of light may not be a cosmic constant at all, but the maximum refresh rate of the universe's processor. The anomalies we cannot explain. Throughout history, scientists have stumbled upon phenomena that defy explanation, anomalies that feel less like mysteries of nature and more like bugs in the system. The fine-tuning problem. The constants of physics, gravity, electromagnetism, nuclear forces, are balanced with impossible precision. A fraction of deviation, and stars would not form, planets would not exist, life would never emerge. It is as if someone calibrated the simulation with exact parameters to allow complexity, beauty, and consciousness. Too perfect to be chance, too deliberate to ignore. Cosmic rays and random errors, high-energy particles from deep space occasionally strike Earth, sometimes interfering with electronics, even flipping bits in computer memory. These random intrusions feel eerily like external interference, as if the simulation occasionally receives stray signals from outside its boundaries. The Mandela effect, collective false memories, millions of people recalling details differently, logos, movie lines, historical events. Skeptics dismiss it as faulty memory, but what if it is evidence of reality being patched, updated, rewritten? A system rollback, where some remember the old version while others live in the new. The observer's paradox. If reality is code, then consciousness may be both its user and its debugger. We notice the cracks because we are not passive inhabitants, we are observers, and observation itself changes the program. Take the double-slit experiment. When particles are not observed, they behave probabilistically, spreading like waves. When observed, they collapse into definite paths. It is as if the simulation economizes resources, rendering only what is necessary when someone is watching. Just as a video game does not render the entire world at once, but only the part visible to the player, perhaps the universe does not exist in full detail until consciousness demands it. This raises a chilling possibility. Glitches occur when the system fails to anticipate observation. When consciousness peers too deeply, reality stutters, revealing its incompleteness. The cracks are not flaws in physics, they are flaws in rendering. The cosmic code. Mathematics is the language of the universe, but it is also the language of programming. Equations describe everything from planetary motion to quantum fields, yet they are abstract, symbolic, not physical. Why should reality be so perfectly describable by math? Unless math is not a description, but the source code itself. Physicist Max Tegmark once proposed the mathematical universe hypothesis, that reality is not just described by mathematics, it is mathematics. Every particle, every law, every interaction is a mathematical structure. In other words, the universe is not a machine running on math, it is math running as a machine. If this is true, then the cracks we see, the anomalies, the paradoxes, are not failures of physics, but errors in the code. Bugs in the mathematical architecture. And like any code, it can be debugged, patched, or rewritten. The human experience of cracks. We do not need particle accelerators or telescopes to sense the fractures. Ordinary life is filled with moments that feel off. Déjà vu, where time seems to loop. Coincidences so improbable they feel scripted. Dreams that bleed into waking reality, leaving traces of impossible knowledge. These are not just psychological quirks, they are the human experience of cracks in the simulation. Imagine walking down a familiar street, and for a moment, everything feels duplicated. The same car, the same passerby, the same sound repeating. You shake it off as imagination, but what if it is a rendering error? A duplication in the code? Or when you lose an object, search everywhere, and later find it in plain sight where you had already looked. A memory glitch? Or a system refresh, where the object was not rendered until later. These cracks are subtle, deniable, but they accumulate. They whisper that reality is not seamless, but stitched together, and sometimes the stitches unravel. The cosmic horror of imperfection. If the universe is a simulation, then its cracks are not just curiosities, they are existential threats. What happens when the glitches grow? When the anomalies multiply? If the system falters, does reality collapse? Do we vanish, not in death, but in deletion? The horror lies not in being simulated, but in being simulated poorly. In living inside a program that is unstable, prone to errors, vulnerable to breakdown. We are not just characters in a story, we are characters in a buggy game, one crash away from oblivion. And perhaps the glitches we see, the Mandela effect, déjà vu, quantum paradoxes, are warnings. Signs that the system is straining, that the simulation is nearing its limits. The cracks are not accidents, they are foreshadowing. The search for the cracks. Scientists, philosophers, and dreamers have begun to search deliberately for these fractures. Experiments probing the limits of physics, searching for pixelation in spacetime, for anomalies in cosmic background radiation, for evidence of computation in the fabric of reality. Some claim to have found hints, irregularities, unexplained noise, patterns too artificial to be natural. But perhaps the most profound search is not in laboratories, but in human consciousness. Meditation, altered states, near-death experiences, all report visions of reality dissolving, of boundaries breaking, of glimpses beyond the simulation. The cracks are not just external, they are internal, woven into the fabric of perception itself. The story of the cracks. Imagine a civilization inside a simulation, slowly realizing its world is not real. At first, they notice small anomalies, stars repeating, memories shifting. Then, larger cracks, physics faltering, time stuttering. Panic spreads. Some deny, some worship, some rebel. Eventually, they face the truth. Their world is ending, not in apocalypse, but in system failure. Are we that civilization? Are we living in the prologue of collapse? The cracks we see may be the first signs of a greater unraveling. The simulation may not be eternal, it may be fragile, temporary, doomed to crash. The invitation of the cracks. Yet, perhaps the cracks are not only warnings. Perhaps they are invitations. If reality is code, then cracks are openings, portals through which we might glimpse the true world beyond. The anomalies may be messages, signals from the programmers, hints that we are not alone. The glitches may be keys, waiting for us to unlock them. The cracks terrify, but they also beckon. They whisper that reality is not final, that beyond the simulation lies something greater. The horror of imperfection may be matched by the wonder of transcendence. The cracks in reality are subtle, elusive, deniable. Yet they persist, accumulating like fractures in glass. Physics falters, consciousness stutters, memories shift. We live in a world that feels solid, yet beneath its surface, the seams show. The universe may be a simulation, and if so, it is not flawless. It glitches, it falters, it cracks. And in those cracks, we glimpse both terror and possibility. Terror that our world may collapse, that we are fragile data in a failing system. Possibility that the cracks are openings, invitations to transcend, to discover what lies. Psychological horror of being simulated. There is a unique kind of terror that comes not from monsters or murderers, but from the realization that your entire existence might be artificial. The simulation hypothesis doesn't just challenge science. It shakes the foundations of identity, agency, and sanity. Imagine waking up one day and realizing that everything, your memories, your emotions, your relationships, might be lines of code. That you are not a person, but a process. Not a soul, but a simulation. This is the psychological horror of being simulated. Existential dread sets in. If you are not real, then what is the point of anything? Love, ambition, morality, do they matter if you are a character in someone else's program? The loss of agency is profound. Free will becomes a myth. Your choices, your thoughts, your desires, all predetermined by code. You are not living. You are executing. Then comes the fear of surveillance. In a simulation, everything is observed. Every action, every word, every thought, monitored by the system. You are never alone. Privacy is an illusion. And worse, you can be deleted. If you are software, then you can be shut down. Erased. Forgotten. The fear of death becomes the fear of deletion, a sudden, silent end with no afterlife, no legacy. Mental health implications are staggering. People who believe they are simulated may experience derealization, a sense that the world is fake. They may suffer from paranoia, anxiety, and depression. The mind struggles to find meaning in a meaningless construct. Some embrace the idea. They see it as liberation, a chance to transcend the illusion. They seek awakening, enlightenment, escape. But even this can be a trap. If the simulation is designed to contain you, then every attempt to break free may be part of the program. The concept of glitching adds another layer of horror. When reality behaves strangely, when time slips, memories shift, or physics falters, it feels like the system is breaking. You are witnessing the collapse of your world. But what if glitching is awakening? What if these anomalies are signs that you are becoming aware? That you are seeing the code? This duality, terror and transcendence, defines the psychological landscape of simulation. Art and literature have explored these themes. Films like The Matrix, Inception, and Dark City depict characters who discover their world is false. Their journeys are filled with paranoia, rebellion, and revelation. Philosophers like Jean Baudrillard and Philip K. Dick question the nature of reality, suggesting that simulation is not just possible, but inevitable. In religious terms, this horror mirrors the concept of divine judgment. You are being watched, tested, evaluated. But by whom? And for what purpose? Some believe the simulation is benevolent, a school for souls. Others see it as a prison, a cruel experiment. The uncertainty is maddening. Support groups and online communities have formed around simulation belief. People share experiences, theories, and coping strategies. For some, it's a spiritual path. For others, a psychological struggle. Therapists are beginning to address simulation anxiety, helping patients navigate the fear of unreality. The goal is not to prove or disprove the hypothesis, but to restore a sense of meaning. Because meaning is the antidote to horror. Even if we are simulated, our experiences matter. Pain is still pain. Joy is still joy. The simulation, if it exists, is real enough to affect us. And perhaps that's the point. In the next chapter, we'll explore the possibility of breaking the simulation, escaping, hacking, or transcending the code. But for now, sit with the horror. Feel the dread. And ask yourself, if I am not real, why do I feel so deeply? Breaking the simulation. If we are inside a simulation, the most haunting question becomes, can we break it? Throughout history, mystics, philosophers, and rebels have sought to escape the confines of perceived reality. In the context of the simulation hypothesis, this quest takes on a new dimension, not just spiritual or intellectual, but computational. Breaking the simulation could mean awakening, realizing the illusion and transcending it. Or it could mean collapse, a system failure, a cosmic glitch that ends the program. Some believe that enlightenment is the key. By shedding ego, desire, and attachment, one can see through the veil. This mirrors the idea of a character becoming self-aware, recognizing the code, and stepping beyond it. Others propose technological escape. If we can understand the architecture of the simulation, its rules, limits, and vulnerabilities, we might hack it. Alter the parameters. Rewrite the script. Quantum physics offers clues. The observer effect, entanglement, and non-locality suggest that reality is malleable. If consciousness shapes the world, then focused intention might bend the code. Meditation, psychedelics, and lucid dreaming are seen as tools, ways to access deeper layers of the simulation. Users report visions of grids, patterns, and entities beyond comprehension. Are these glimpses of the source code? Some theorists suggest that the simulation is designed to prevent escape. Like a game with invisible walls, it redirects, distracts, and resets. Every awakening is met with confusion. Every breakthrough with silence. But what if the simulation wants us to awaken? What if the purpose is evolution, a test of consciousness, a journey toward transcendence? Cosmic glitches may be signs. Unexplained phenomena, time anomalies, and mass awakenings could indicate that the system is faltering, or that it's opening. The idea of collapse is terrifying. If the simulation ends, what happens to us? Do we vanish? Transfer? Reboot? Some believe in a higher reality, a base layer beyond the simulation. Breaking through would mean returning home. Others fear that there is no beyond, only void. Art and fiction explore these themes. Stories of characters escaping virtual worlds, confronting their creators, or merging with the source. These narratives reflect our deepest hopes and fears. Philosophically, breaking the simulation challenges identity. If we are not our bodies, our thoughts, or our histories, then what are we? Pure awareness? Data? Echoes? Ethically, it raises questions. Should we try to escape? What about those who remain? Is awakening a privilege, a burden, or a responsibility? Some propose collective awakening, a mass realization that shifts the simulation itself. Like a dreamer becoming lucid, humanity might change the dream. Others warn of danger. If the simulation is fragile, too much awareness could destabilize it. The system might crash. Reality might unravel. In the end, breaking the simulation is not just about escape. It's about understanding, seeing the illusion, embracing the mystery, and perhaps becoming the coder. As we conclude this journey, remember, you are more than you appear. The world is deeper than it seems. And the glitch might be your awakening.